All right, we finally got the live stream going. Welcome to the Live Coding Alliance. I'm the founder, Cale, and we're working on some open source stuff. I'm building a 64-bit UUID library based off of a distributed DSP cryptographically secure random number generator. It works by storing, whenever a client requests something that requires generation of a UUID, this client will submit a random number. This random number is going to be positive or negative, and then they have a positive or negative exponent. So when you add 12 random numbers, it forms a normal distribution a la central limit function. And this allows us to filter out numbers that are not cryptographically secure. Because really, the thing about a cryptographically secure random number is that it forms a normal distribution. All right. So it's more important actually that the exponent is random than having the lower bits be completely random, because you're trying to form a normal distribution. So you got to think about it in terms of like, I'm adding up a bunch of, just think it's like 1.0 something, whatever. Like it can't, like the decimal place is never going to be really that much. It's always going to be the most significant bit is going to be the thing that's like determining whenever you add up these numbers, whether or not they form a normal distribution, right? So I'm hacking this, right? So what we do is, how many exponents we got in a 64-bit float, right? We have 512 plus a sign bit. Okay. So the sign bit and the exponent sign bit essentially are random, just like the lower bits are random. But the thing is, the exponents now, they all have to add to be a random distribution, right? So we're taking 12 user generated random number. Then we take the buffer, we sum it up, and then we XOR it. So that generates a random bit pattern. So from this, we're going to determine what the exponent is going to be. We're going to use the bits in order to XOR a bunch of samples together. But this time, we're bumping from 12 up to 16. So first off, so we take the 12 client-generated random numbers, sum and XOR them. And then we take the output. So the output that goes to the client. Wait, sorry. No, it has to go into the bucket of 512 buckets of 16 cryptographically secure random numbers with just the regular Mersenne twister algorithm. It's programmable. You could swap it out at runtime. So then we have 16 samples, right? So that we have 512 exponent integers plus an extra sign bit, but we're just throwing that out. Actually, I could bump it up. I might make it so that it's actually like 1024. I'm going to experiment with both of those, because now that I think about it, the more random numbers, the better, because it's not really actually that much. What do you got? 512 more times 64 bits is 12 times 64, that's 32K. We're only at like 64K of RAM. So what do? So we take the 12 XOR number, the 12 last client generated XOR numbers. Then we get a pseudo random number when we XOR them. It's not completely random because it is a subset of the 12 numbers, which, you know, even though it's an XOR, like it's not a complete subset, but it's random enough in the lower bits. You got to think, you know, going back to the cryptographically secure, meaning that it's going to add up to a normal distribution. It's not going to be skewed with the Gaussian curve to the left or the right. It's going to be centered around the center. So whenever the client generates a random number between negative infinity and positive infinity, then that's going to be, so let's say it was a random number between -1 and 1. That is a 63-bit number because the exponent of the floating point is positive or negative, and the mantissa has a hidden bit. So that's going to turn that into 54 bits, and then you're shifting those up and down. So we're not going to use, because we're taking the random numbers and sticking them in our buckets. So this means that we can we got our pseudo random number, and the least significant bits are about as random as you can get it. When the whole part about the cryptographically secure is whenever you sum up a lot of them, then it, you know, normal distribution. Sorry, I've said that multiple times. So we have to pick a bucket. So this is going to mean that we're going to take the lower 10 bits. I guess now I'm going to bump up the 1024 buckets for right now. And then we are going to utilize the other 16 bits. Sorry, the higher, more significant 16 bits. And that's 26 bits. And then we're going to take that bit pattern and we're going to XOR together the samples in that bucket. So it's like a ring buffer. So each time I take that number that I generated from the client by the client generated numbers, and then I put that in the bucket with, I might XOR it with the last sample, or I'm trying to recycle these numbers to be able to swap them out. So the reason why I went, the first bucket had 12, because we're trying to filter stuff out, because 12 is when it turns into a normal distribution. Then in the buckets, the numbers are, we're going to XOR them, and so the exponent bits are still going to be there, but we're not going to use them because we already have the exponent bits because we stored them in these buckets, right? So now I can take these bits out and then put them into a buffer where I can store some number of bits. And then I want to take some sort of other randomness, like maybe I might generate one random number per second. I'm not sure whether or not I want to do that, because I like the idea personally of, if you are requesting a UUID, you need to give me a random number. And then I don't want to generate any random numbers on the server. But we have to have some sort of level of randomness, that is programmable to where it's going to be usable on a standard server with a relatively small amount of RAM. So already, you know, if we're using 64 kilobytes of RAM, I would say that we're starting to like compete with my other 2 gig memory limit that I'm not that happy about. But that's just the, you know, the cheapest servers are going to be running on that. So we need to be hitting that target. And if we don't have to generate any sort of random numbers, that means that we're going to be able to serve a hell of a lot more people with the, what do you call it? Forget. So I don't even think, yeah, we're not going to really have a random number generator in memory at all. All right, so now I'm going to get into the live coding because I think I've lost my train of thought. All right. What do we have? 12 sample count. The one thing I'm not sure, like, if it's just that like you add 12 random numbers that they start to form a random distribution, or if that's like the minimum number of samples you need, and then I can keep adding more samples, and then I'm not sure exactly how that works with the DSP thing. I did not take the DSP class in engineering school because they pulled it from the curriculum. I went to the college to take that class, and then they pulled it. I was not very happy about that. But I remember looking at the book, and that was just like the only thing I remember from the entire class was you add 12 random numbers, and then it forms a normal distribution, and then you can use this to filter out noise. Like, okay. So I guess we're winging it, but sample count. See, because I need do I want to increase the buckets to 12 from 12 to 16? I can just I'm just going to call it a bucket count, and then it's 16. So I have one big, because we're in TypeScript, so I don't really want to have what? I don't want to have any memory overhead. So if I could just take this thing as sample, and then wait, sample. This is the oh yeah, random filter server. I don't know if that's what I want to call it. I could call it random distributed server. I mean, random distributed generator server is random filter server. Should I just take out the server part? Distributed generator. So there's reject, there's trash, and then I need to get another bit. So I need to like have a big int, I think, where I need to take the exponent bit and then mask those off. Fair fit. All right. Uh, 12. This isn't right. Samples. This has to be. Hold on. So right now, what am I doing? I mean, I might just bucket count. No, there's two things I could do with it. So we have the mantissa part of the float and the we're trying to say. So we have a 64-bit float. There's a 10-bit exponent. Okay, so that means we have like the lower bit and then the upper bit, and I have to deal with the randomness of the. So let's just say we chopped off all of the mantissa, and all that we had left was the exponent and the sign bit. So the question is, how the hell do we want to go about ensuring that the numbers are as random as possible so that without having a large overhead? Because we don't want to generate any random numbers at runtime. I would prefer to, like, I want to recycle the random numbers the clients give us and then do something to make it impossible to unscramble them. Like, but I don't want to use a megabyte. Like, I'm freaking out about 64K. I would say that 64K is like, I'm starting to worry about the size of whatever I'm doing. But a Mercian prime generator is very large, and it takes a very, very long time to run. So the question here is, I could do 512, 1024, or I could do 2048, which means that I have to generate 2048 times 64 random bits. Well, hold on. No, I need to generate the mantissa. If I set this to, hold on. Wait, I don't like bucket. I'm going to call it bucket size and bucket count. So I'm going to call it the bucket count is the always, with me, size means bytes. Hold on. So the count is the count. Yeah. But then the size, this is kind of ambiguous. So generally, size to me means bytes, but not always. And then, so what is this? It would be, this would be if I did not store the exponent bits. So there's 10 exponent bits, and then there's another sign bit. So the options are make that 1024 or 2048. If I did, what's the benefit of 2048? So in order to add them up to normal distribution, I would need 2048, which is going to be that times 16 times 64. So that's 2 megabytes. I mean, it's 2 megabytes okay for a random number generator? I would say that 2 megabytes is getting to the point where it's going to be very difficult to crack that. So how will you go about, so this is going to be running on a web server, and then somebody's going to make a request to a web server. And this is a little bit where I have a problem with this, because like I need to be able to spawn a new web server and then not have it chunk, because I would be creating a 2048 plus how many? Like another 12 times. Wait, no, it's 2048 times. Could just do 12. 12 samples. Wait. Plus 12. So that's one. If I bump down to 12 samples, that's 1 point. Wait, I probably should be doing this on screen, huh? This would save half of a megabyte if I only. Why was I bumping up to 16? Because I wanted to scramble them up. So the idea that I'm thinking in my head is that I'm trying to generate a UUID. Okay. We can't have UUID hacking. All right. So if you're the military and you need like military grade security, like, I'm sorry, I'm a little player. I just can't even serve you. I'm trying to serve like Joe Schmo who's got like a business, you know. If you're I'm not trying to have like a 512-bit security key using some sort of circulating temporal key system. That'd be crazy. I need to just do the nuts and bolts. So the sample count is 12. This is worthy enough. But, well, didn't I put this at the top? Well, bucket count. 2048. Plus 12. Bucket count. What am I calling a bucket? A bucket has a bunch of samples. Bucket size. Sample count. Bucket count. Just get rid of this for right now. Reject count? The reject. So am I like putting rejected numbers in a buffer, and then I have to like okay, so this part I don't have figured out. So public start, public stop. What is that? This is the I don't know if I need to do this anymore. So what was my first thing that I was doing? I had the 12 samples, and then I was XORing them together. And then in my mind, I thought that I would just XOR them and then send the XOR of the last 12 random numbers. But now that I think about it, I mean, that's probably good enough, but just having more buckets with random numbers and then just like doing the exponent and then just using the buckets for mantissa. And then I can use the mantissa and I could use the exponent and the sign bits in order to, anytime I generate a random number, I'm going to end up with 11 extra, mostly random bits. I don't know. So I'm summing up 12 random numbers. It forms a normal distribution. Mostly the LSB gets ignored. It's not going to add a giant amount to the result. It might add like up to 50% more, in the freak case. But it's only going to add like a little bit more. So in general, we can just look at just the exponents and the sign bits. And when we add them up, let's just chop off the mantissa. All we got is a floating point with just like one bit. And then we're shifting that bit up and down. I mean, I think the exponent bits are just random. So I get the random samples, I XOR them together, and then the first 10 bit, I'm going to take the first nibble that I take off is going to be for the bucket. So if I do 2048, that's going to be 11 bits. Right, I got like, how many random bits? I got 53 random bits in the mantissa, so there's a whole bunch of bits. And I think what I need to do is I'm going to cycle through in a ring buffer and then replace the oldest sample in the ring buffer. And then I want to XOR some number of the samples together. And I think I'm just going to keep it at 12. I'm not going to go up to 16 like I started saying at first. I'm going to be doing just the 12 because the memory is starting to get large. Like 1.5 megabytes is like, if you ask me, that seems to be appropriate. Like if I had 2048 times 12 random number. So these random numbers are not client generated. Times 12. I would have 24,576 random numbers. Even if I just stored, if that's all I did was I stored a bunch of random numbers and then like XOR'd one of them and did some sort of scramble genetic algorithm thing or whatever, I could probably get away with just that. But we can do a lot better. So we'll just keep saving up these bits. So we'll generate a random number based off of the XOR. My rabbits running around. History. I don't think I really want this stuff anymore. Public start, public stop. I think I'm just going to do the 12 samples And then so I don't want my my numbers coming for the randomness of the exponent to come from the public, from something that happened recently. I need it to happen like in a buffer with maybe another like 512K worth of extra random bits. So because I have these now 2048 buckets of 12 random numbers that I generated on the client side, they're never going to be public. Okay. I'll generate them either on the cold start server. Maybe I need to have this thing. I think the plan is that I want this to run in a different thread to generate the random numbers. And then when the server cold starts, what I want is I want a server to be generated with a set of random numbers. So when you start a server, I should be able to send it a boot up request. And then while that thing is booting up, I would like my master server to generate all of these random numbers and then send the random numbers over. Maybe whenever it boots up, the server gets like 100,000 or whatever random numbers, probably just like 100 or so, or maybe even 10, something like that, just because it needs to store the UUIDs. So, or maybe you could have, yeah, I would probably just send it just some random. So I'm just going to get rid of this. I don't really want this. I'm just going to take the 12 random numbers because now that I have more buckets, because I didn't have anywhere near as many buckets. I had like 64 random numbers that I was doing something different that was kind of similar, but this is just a way better technique. Public start, I don't need that. So a reject count, maybe I need that. Spare bit count. Wait. This dot spare bit count is equal to, wait. One shift spare bit count. Yeah, those bunnies are getting at it. $64K. I don't know about that. 20. Right, 64, 120. Right. No, 18, right? 2 to the 18th is 64K, 128, 512K. Right? But wait, is that 512K divided by 64? What's how many bits is 64? Six bits, right? So 12. Or maybe I'll just make a number out of it. Spare bits. I would rather have array spare bits is going to be a number now. And then I'm going to call it spare bit count. And then I'm going to do spare swap number. All right. And then, so spare bits is going to be 0 at first. So spare bit count is 0. Yeah. What? Spare number count. Right. Bucket count. So this is going to give us what about, hold on, let me think about this for a second. So when you add up the exponents, then the exponents should like average out to 0. Okay. So now let's say that I wanted to do the, I'm going to have to bump down to 1024 because the way that I want to do this is I want my random exponents to be decoupled from the bucket bits. I'm just going back down to the 10-bit exponent bucket count. 1024. And then I'm going to take the random number that the user gets. So we're going to take the, all right, let me go back to the beginning. Client submits a random number. Random number goes into my 12 sample count buffer to filter out numbers that do not match a normal distribution. So I need to eliminate the ability to hijack this distributed number generator. So I need to, the randomness that I get in my buckets, I need that randomness to not be able to be hijacked by people who are requesting UUIDs. So, and we also need to make sure that we have a proper subset, because we need to be able to generate a public password, which is not as much of a need to be cryptographically or completely random. So when you say cryptographically secure, this means that it forms a normal distribution. It does not mean that it's perfectly random. Okay? But we are generating we also can generate source ID, anonymous source IDs. So we got our 64-bit UUID format, contains a 28-bit timestamp, a 7-bit sub-second ticker, or sorry, an 8-bit, hold on, let me rephrase that. I think I have moved to a 6.4-bit, sorry, a 7.5-bit, almost 8-bit sub-second ticker. And then we have the 28-bit source ID. But if the sub-second ticker is I think it's like above what, 192, or wait, I think it's going to be it's going to make, if it's above a certain value, it's going to make a 34-bit. We're going to combine, it's not going to be a sub-second ticker. It's going to be random bit. So maybe it could, let's just say it's 7.5-bit sub-second ticker. If it's over 192 in a second, then all you can do is anonymous source ID. So the idea is that sometimes we want to conceal when something was generated at. Like, let's say I am like Falun Gong. I'm persecuted by the CCP. They got like people trying to track me down because I'm a dissident. They're like dictators. They're horrible people. And then let's say hypothetically, I also have a abusive ex partner who's trying to track me down. Right. This is the thought experiment that I have been using the entire time for this. So I just need it to be good enough to where you can't guess the number. But I also need it to be able to generate the anonymous IDs, because think about it from the perspective of I have like a database and I'm making database calls, and these database calls, like a write, a create, you know, this might take 100 milliseconds, right? So you don't really want servers to generate unlimited numbers of UUIDs per second. You know, a random number generator takes a long time to run, so it kind of caps a system. Although you could have a distributed system that's coming up with random numbers in order to do like a denial of service attack. But right now I'm focusing on the public password portion. But yeah, we'll just hijack these extra bits in order to store a bunch of extra bits that we generated. Like we only, in the bucket, we got a number, 12 numbers, 12 samples. And then we are going to generate a pseudo-random number. That pseudo-random number is going to go into some sort of other scrambler. But the thing is that the scrambler needs to be guaranteed to scramble it up enough to where it's going to result in something that's not going to cause a lot of collisions. Because this is the difference between a truly random number generator and a cryptographically secure one. Cryptographically secure one is just good enough to not be correct, so that it's forms a normal distribution when you sum up the values. You don't have like a skew in the Gaussian curve to the left or the right. So the spare swap number is going to be just for go through and generate a random number. So we got a sample. How do you check to see if it's a real number? No, I'm looking to see not is it nan, it's like it'll like what, how do you just check to see if it's a legitimate number? I'm not looking for like, not, oh, here it is. So wait, is that what their question was? No longer doing the number between -1 and 1 because I want to use that extra bit, because if it's between -1 and 1, then that's a 63-bit random number. Random number. What are doing here? Oh, so what am I doing? I guess I did have it. I had a set of 12 of the last random numbers generated. So I had 12 of the last samples, right? And then I used that sample for the last 12 numbers generated. So yeah, I have to store the last 12 numbers generated. The first set is the samples. The second, didn't I say that? I mean, it makes more sense to make 0 through 12 the samples. What about the initialization here? I'm going to do the initialization first. Reset. Hold on. I don't really want to reset this. I want to reset it externally. I don't really want to have this random number generator in here. Although it's just a function pointer, and I can replace that with a another pseudo random number generator. Wait. I would prefer to pass in the random numbers externally. I mean, it's just a function pointer, so I could just have some sort of like functional component that I could swap out, but okay. I guess it's just easier to just export fun number. Wish they called it fun instead of function. Take all the fun out of it, dude. Number non-z. What do I do? How do I get to the lowest and highest number? Number, max value, min value. I should remember that, but I don't know. I haven't been programming TypeScript a lot. Let generate 0. Max value, min value. All right. Well, it's not really significantly different from that, huh? That's okay. The way I work is if I didn't specify it, then it's, any of them. All right. So reset. Okay. Well, this sample count. I don't know. Does JavaScript optimize that stuff away? should, right? It's TypeScript, so it's going to precompile it. Right. So what is it? I need like the last 12 random numbers generated, right? What do I do? Sample count. I'll do sample total. Huh? 2 times sample count plus just a bucket count. Okay. Whoa, so much real estate back. Shit, son. I don't know. I don't really think I like that. I don't like most people's style. I mean, I like consistency. I'm not totally anal or retentive. I do like sometimes doing stuff just to piss other developers off. Just because I'm fucking with you. Usually pretty, you know, I'll put stuff in like a reverse notation just because I know it's like, for me, my brain already, like, it works just fine like that. Then I know for other people, they're like, oh my God, you're not allowed to do this. Basically, if it challenges your dogma, you can probably bet I'm going to do it. Just reset. Wait. Hold on. What am I doing? I'm filling up the buffer. Okay. So this is the first time it's going to run. I'm going to have 12 random samples from the client, and then I'm going to have the last 12 numbers I outputted. All right. I don't have that. I could probably just stick this right here. I kind of want to decouple the random number generator from it and just pass it in. That would go from that to okay. That worked pretty good, man. To be honest, my TypeScript skills aren't really that great. So that was actually pretty helpful for me. Can I just do this? Oops, that wasn't the right thing. Can you do that? How do you do a multi-line string again? No, I can't do that with this, huh? Oh man, this is totally triggering me, bro. What do I do? Yeah. Pressing the wrong button. Right. I'm anal about the 80 character columns. You know, when you do live coding stuff, you don't really have room to, like, we're dealing with old dudes with bad eyesight, you know, so I got this big font. We don't got any room to spare. The reset. So I'm doing this from this way because I don't want, all I'm doing is just generating a bunch of random numbers. So, what do I do? Oh shit, what do I do if I hit? Yeah, I can't have this in here. Hmm? Okay, so do I need to like? I don't think I want any of these here actually. 'Cause I'm sorry, I'm just not that good at TypeScript, dude. You'd think I'd be good at TypeScript by now, but I'm sorry, I'm a loser. I'm not cool like Theo. Not woke enough, I guess. I like Theo. I'm not bashing Theo. Don't get me wrong. Man, is he woke, dude. Oh. What a soy dev. For real, bro. Sample count times bucket count. Now I'm gonna have to do a sample count. Wait, bucket total. Okay. Oh wait. Number value for each. Wait, what am I doing? Huh? I might not ever need that thing. I mean, I could probably just. I want to update the random numbers asynchronously because I might just want to have like a thread that's generating random numbers, and then every once in a while I just update random numbers, and then who cares, whatever stuff could change out with like some sort of what do you call it, race condition or something that would still be okay. That would be the preferred method. We don't run reset. Do I run reset? Reset. I don't particularly think I need this. Right? Oh wait, sorry, I'm looking at the wrong one. Where's the reset? Here it is. I need to move this up to the top or something. I don't know. Total. Go over to all these errors. Probably up. That's what this is. That's that. Yeah, I might want to just take out any reliance on a random number generator or the history start. What's this? XOR sample. I don't want to deal with that. I think that one might have to go. And this one's just a bunch of random numbers, huh? Because this new setup, I just have the last 12 client generated random numbers, and then I got the. We keep a look on that. Yeah. Oh shoot. Sorry, somebody chatted. Sorry, I didn't notice that somebody chatted. I'm building a database called Subsecond DB. All right, what do we got? Sorry about that. Oh, I was staring at the scope doc. Usually nobody's chatting, so sorry about that. Maybe I should have the. Oh, I have a webcam. Where is it? Overlay. Oops. Nothing here. All right. So what's going on? I'm actually like finally starting to like figure this stuff out. So we got for the reset, we just go reset all the samples, and then need that. Right. Reset count. So what do I do? Spare bits. Oh. Index. Do I need to reset any of this stuff? Spare bit. Count. Swap numbers. So I have 12 Mercine Prime generated numbers for the input and for the output, and then for all the exponents. And then I think I'm just ready to just grab a number. So I think whenever you grab a number out of this, what I'm going to do, we XOR samples to get match point. I probably need a probability that any one of these ones is bad. So I might end up having, because whenever we're generating random numbers, I need to keep track of the distribution. So the distribution is going to be on a per the distribution is going to be on a per exponent basis, because you could have just a 1-bit floating point number, and those things can add up to a normal bit, sorry, whatever amount of exponent bits You just got one, let's say it has 0 mantissa bits. Then you're going to sum those up, and then it's going to cluster around 0. But not all the time. So there are situations where that doesn't actually occur. Generally, that means your number algorithm, your number generator is not actually being random. For us, we are generating our random numbers on the client. So we can't trust them. All we can do is trust that they're probably going to try to hack our system, or that there was a network error, or there may have been a network error, shall I say. Then that's not the one I'm looking for. Where do I just XOR samples in a range? Start and stop. This one? Wait, that's not what I'm wanting to do. So I take the last 12 random numbers and then I XOR them. And then I would prefer to like delay utilizing these bits for a while. But right now I can't really deal seeing that far into the future. So this I'm switching it over to I don't just want to XOR. I think I'm going to XOR the last 12 bits, and then I come up with an XOR. Maybe I throw that into some sort of buffer. Like I could throw it into a black box, and then it just comes out the other side. A more secure random number comes out the other side. So oh, right, that's what I needed. So I did need actually 3 of these. Because I forgot. So I had the last 12 samples. I'm going to store the last 12 XORs. And then the last 12 numbers produced. Right. What would that help me with, though? I can't do anything with the last 12 numbers produced because those are just for verification. I have to have some sort of private pool of random numbers that I'm able to generate other random numbers with, because it's, you know, I've got my public. Let's say that we got CCP snooping on the line, trying to track down Falun Gong dissident, some Uyghur Muslims, you know. So they're hacking us with their A team. All right. So what would storing the last 12 XORs tell me? So I stored the last 12 samples. Okay, and then I store the last 12 XORs. And then I store the last 12 numbers produced. And then I store, what is it? 1024 buckets of 12 random numbers for the exponents, because there's a 10-bit exponent. And then I take off those 10 bits. Each time I generate a random number, I end up with a random 10-bit number. All right. Now I take that random 10-bit number and then do what? Maybe I could rant. What am I doing with 10 bits? Maybe that could be the exponent next time. Exponent. So I need to go from I need to go from my 12 client generated non-trustable numbers and then throw in some randomness, and then so that could be the exponent bits, right? So what does that do? Maybe I could just take the exponent bits whenever I generate a random number, and then that's going to be the next exponent bit. Because I would prefer to just, like, the numbers in the buffer are known to be cryptographically secure. They form a normal distribution. All right. Within some acceptable tolerance. So yeah, I like how I'm building this Postgres extension with a TypeScript first experience. And then drizzle ORM, because I think that that's going to be a slick little extension. So we take the last 12 XORs, right? Then I could take, maybe I can verify that the XORs are forming in normal distribution. I don't know. I don't really think I want to do that. So we have 10 bits. What I could do is I have two options. One option is I just save up these extra 10 bits that I'm generating each time. The other option is that I utilize these 10 bits maybe to store the next exponent that I'm going to generate. So I got the XOR of the client submitted stuff. And then I get my next exponent. So then I'm going to take a sample out of the buffer, and I'm going to replace that sample. So now I have a random number. All right, when I take it out of the buffer. I could just return that to the client, and then I could take the 10 bits, stick it into a black box that loops back around. It seems to me one of the most random ways that I could possibly scramble the bits is by taking a 12-bit number and then a 10-bit number, and then I could take the 12-bit, no, it would have to be a 12-bit number, and then I could take, for each bit that's asserted, I could XOR some of the samples together. Maybe I can do that if I detect it's not a normal distribution. That count. So what's the spare number again? Oh, so I have two options. I can do a black box. Yeah, I started doing this bit, the spare bits. Let's XOR this sample together. XOR sample start. So I guess what happens when you XOR 12 normal distribution random numbers together? That's the thing. I don't know, like, what the subspace of that is going to be. Oops. Oh, get out of here. Oh, shoot. Oops, sorry. I'm having troubles here. Boy. Ooh. Keyboard shortcut hell going on. I just have to stop using the keyboard shortcuts. Next pseudo random. Right, so I XOR'd them, and then I had a list of pseudo random numbers. Pseudo index. Last index. Sample. Pseudo index. This I don't think I really need anymore. Reset count. Don't know necessarily if I need this. Samples per bit. Oops. Spare bits that are not used yet. Spare bit counts, leftover bits. Could just use a big int. Fair number. Oh, right. This is the decision if I'm doing a black box or if I'm doing a buffer. Because if I did I would have to delete this because it would have to be in the samples. No. My bunny's making weird sounds. She's the loudest rabbit you'll ever hear, bro. She's like, she always wants a pet. She makes weird sounds when you pet her. Let's see. 84. Shit, it's point. Here's the black box method. So I have a little bit of a black box and a buffer method going on at the same time. To trash. Reject and trash. My thinking with this was like, maybe I was going to swap these functions out at runtime. Like maybe I was like gonna like maybe it don't I pass a number in and out? I could do like a recycle. Trash. I just don't. I'm gonna comment these out and try to get rid of them. Keyboard shortcuts colliding. Pseudo index. Oops. Oops. Pseudo random. I don't think I'm doing this one anymore. Oops. I'm gonna have to change that. All right. Four sample. I don't know what to do about this. Don't really think I want to deal with that. I just have to check for 0 again. All right. Okay. I wonder if I should just put bucket number. I'm going to do this. I'm going to do bucket number. Greater than. Oh, I need bucket total. Okay, that works better. Pouring the samples together. Yeah. Okay. Well. What is in here? Sample. It's not sample. But this is a con. I'm sorry. I'm the weirdo doing chain mirror case. It's just not that bad, dude. Just give it a chance, dude. It does not look that bad. I mean, for real. Some people hate that shit, dude. But they all tripping, dude. Okay. I'm trying to think about the utility of storing an XOR, the list of the last 12 XORs. XOR random. I really want this. No. Don't think that I actually want this. Next random. Is this like this? What do we do? Don't we do the distribution? Next random. I think all of this is junk now. Just start over here from the start. Do I need the RNG in here? For right now, I don't really want it. So do I need to like XOR sum the thing? Programming in C++. Too much, I guess, right? Excellent. Plus 12. Times what? Sample count? Plus bucket number times -1, right? The bucket 0, I would do a bucket number 0 times sample count. No, I gotta do a plus sample. Yeah. Or no, bucket number plus one. Right. Minus one. So we'll just bucket 0. I mean, I could like make bucket 0 be the input. Or number? No. We do it then. All right. Huh? Oh. Bucket total minus 1. Okay. Yeah. Okay. Seems like this should be a. I think that should be there. If I need to check the samples line. Maybe look up sample that line. Don't particularly want to do this. No. Now I need to go. So let's do the that sample there. You know, it's good, right? Yeah. What do we do? Let me fix that. So what do we do? So I took my input samples. I don't think that AI stuff is that protected. I mean, technically, it wouldn't really matter. I mean, I'd rather just like have the index be valid. Maybe I need to check it for memory integrity purposes. What do I do? Okay. Oh, that's it, right? Okay. Doesn't matter. They're both the same. Just the zero. Zero. Number. And now I have an XOR. All right. Maybe I need my last random exponent here. Fair bit. So I got my XOR. What do I do with the XOR? Right now, I just want to like store the last number. Reset count. No, it's not a big one. XOR. So I'm gonna have to set the last exponent XOR. No, I'm just going to make it 0. It'll be fine. Okay. So I'm going to take this XOR. It's not last. Okay. So now we've basically randomized the lower 10 bits. All right. Now we're going to use this to select our exponent. All right. Hold on. Yeah. Equal to 1. What's happening here? What do I do? Like what? Console log or something? I don't know what to do with that. It's not supposed to happen. Wait, wouldn't I want to put... All right, so X oriented with 0 is what I want. So what do we do? Pull out the last random. The last exponent. So what is this? What is this, like the exponent? Wait. So XOR them together, and then why is this like feel like it's not well thought out? I like the idea of just using a black box. Like whenever I take this XOR, I could like maybe I could have a buffer that I put it in, and then I grab another value. Because the thing is I want to prevent UUID hacking. So, and I want it to be like completely random, because if I'm generating a lot of them per second, then I'm gonna have a problem. Maybe the client could generate 2 random numbers. So is the XOR... I don't like the idea of picking my exponent based off of the XOR. There's something that tells me that I should just black box it. And then develop another system that verifies this. But I also kind of think it might be going a little bit insane too. You know, how many times do we need to do that? Infinite. I don't know. Wing 10-bit. How did it know that? That's strange. What's this? Ring. And what did we do? Another XOR? Wait. Wait, hold on. What's the bucket? We don't need to take a sample out. Wait, I need to do const eject sample. Don't hurt my back to sit like that. All right. Wait, we're in some. So do I have to take the object user sample? No, client sample object. Okay. All right, so we got object sample client. I don't know exactly what I'm going to do with this right now. Eject sample. Okay. And I'm not going to do anything with the ejected. Whatever. All right, so now I take the XOR. Hold on. So I got my XOR, and then I need to do const control equal. Right now, I'm just going to call it the XOR. And then the last exponent XOR. Okay. But isn't this one like the last exponent? Well, we want to do that. So I'm taking a sample and I'm injecting it. Okay. Oops. Okay. So what do I do? Do I store like? Do I need to store like a history of my deviations? And then maybe one of them's okay. Mm. The bucket, right? I need to like, um, what do I need to do? Like convert this into the standard deviation? Okay, so what do I do? Do I take the okay, so wait, hold on. This dot last exponent XOR is equal to XOR 2 on 2 shift was it 52? Alright. It, I think about that for a second. And right, there we go. What I need to do? What con? the exponent. Okay. What does this do? Bucket sum, bucket XOR. Why is this yelling at me? Declare does not exist. Really? Yeah. All right. Is this? What I mean? I don't get it. Huh. Uh. So what do I need to do? Have a function that says like is normal? Do I need to store like the last, like a list of some sort of list of the deviation? So you got the 12 random numbers, you sum them up, they should be around 0. If it's not around 0, then there's a statistical deviation. Okay. So What do I do? This is the point where I got to figure out exactly what is going to happen here. So when I create the thing, you know, I had these function pointers to recycle the thing, and then I was passing in the random number generator. I kind of think maybe it should, you know, if I just black box it. So let's say there's like a problem with the how do I calculate the deviation from what do I do? Like I square the deviation, right? Is that what I do? I store the squared of the deviation. Yeah, because I have to. I'm doing a statistical analysis, right? So the next step would be to square um, the sums, right? So then I take my squared values, and then I'm going to do some like looking for like covariance or whatever, because it should just like turn into a Gaussian distribution. I'm going to go to the bathroom and grab an energy drink and come back. I'm going to crack out on this because this is like legit interesting. It's hard to deny this is not legit. So I need a the next step is to like figure out the strategy for how the hell I would go about like if it fails my standard deviation test, like what I would want to do about that, because I also had my so this one is XORing all of the samples. And then the other option is to XOR together some number of the 12 samples. All right. How do you calculate a standard deviation again? I haven't done that in like many, many years. What am I calculating the deviation of? All right, looks like I have some cinema lenses here. Ooh, they are sexy. Ooh. I was not expecting to have money for cinema lenses, let me tell you. It's like, wait a minute, I could shuffle things around and, whoa, cinema lens. All right, so what am I doing? So I add up the deviations and square. So I'm showing the deviation from all of the random numbers, right? What? Bessel's assumption? I don't remember this one. Bessel's correction? So I'm taking the random number and then I'm comparing it to all of the last 12 random numbers, right? To look for the standard deviation between the numbers, right? Do I use Bessel's correction for that? That increases the mean squared error of the estimation. Okay. So I have the last 12 numbers, and then I have a deviation from them. Okay, and then but then what do I do with the extra number? What's up with these cinema lenses? Oh, cinema lens. Ooh. Ooh. Any damage? They were cheap. $500 for 3 Sarui sniper autofocus cinema lens on Amazon. I was able to take back some stuff. Ooh, afford it. Oh my god, they look so pretty. They're white. Sorry, teasing you. Over here, do I even have? Lady? Sorry. Dealing with an M12 lens here. the 24, 33, and the 56. Right? There's a 55. Autofocus. They're pretty slick. Got an Sony A6700. Yeah, those would be really good on the A6700. I mean, I was like really wanting to try shooting with some prime lenses just because, you know, I've had a zoom long enough where like I don't really think about like a 35 millimeter versus a 27 or a 28 millimeter versus a 40, but like, you know, the 35 is a good focal length lens to get yourself accustomed to. Because it has perspective distortion that is interesting. Very pleasing. All right. So now we're going to calculate up the standard deviation, right? All right. Just calculate up that standard deviation, Cale. I like the black box thing for if we have a failed sample person. All right, so let's now we're going to calculate standard deviation. All right. So what? All right, const. Deviation is equal to new array bucket count. No, not bucket count. Sample count. I don't like the AI generated stuff. I mean, it just doesn't. Sometimes it's pretty cool. I just kind of wish I could press a button in order to generate something. I don't find this AI code generation to be productive. It always generates the wrong thing, and I have to go correct it. I might as well just type it in myself. All right. So new array, and then what do we have to say? What? Deviation dot for each, right? What is this? What did it just generate for us? Equals, dude, this is crap. This is absolute horseshit. What the hell? Underscore? Yellow. I mean, I'm not opposed to I. I'm not one of those people dogging on I. Everybody knows I as index. Everybody knows DN is D's nuts. Damn it, these pieces of shit. Put tape on the case. How would you put tape on the case? I don't know, man. I bought this thing to get the case, and then they like ruin it with this stupid tape. You can't just like stick tape on this thing. I don't know, man. Just fucking irritating. Stick tape on the camera lens case, dumbass. Some people just don't think, dude. Oh no, they put what? They put a sticker with tape on it. A jackass. It says like new condition. The big ass fucking sticker is gonna ruin the. God damn. What kind of idiot would do that? Some idiot who doesn't care about the camera equipment. Oh great. Oh great, yeah, they. Yeah, I might just return this. They ruined the case. Yeah, the case is ruined. I cannot believe they ruined the case like that. Why would you put stickers on a freaking cinema lens case like that? Sorry. Now I'm upset. They like ruined my cinema lens case. What kind of idiot would stick a sticker on a case like that? Sorry, I've already said this multiple times. It's just so frustrating. Why on earth would, I mean, I deserve to take it back just because like that's the most stupid thing that you could possibly come up with. Well, I guess I have to file for a return. Damn it. Okay. Sorry. I bought the 3-lens set to get the case, and then I can't believe they stuck stickers on like fake. What kind of moron would stick stickers on fake leather? I mean, that's just the most bozo moronic thing. I need to return it just because this dude is so stupid. Like, you need to see exactly how dumb what you just did was. I mean, I might write the company and be like, yo, can you send me another case? Because some moron ruined this one, but sometimes they like to, like, help people out. That's just so frustrating, though. Sorry, I'm still mourning my cinema lens is now being gone. Okay, so what do I do with the standard deviation once I have a standard deviation? What is the standard? What am I doing with the standard deviation here? What is the is it like isn't the area underneath the thing pi? Right. So the bound is would it be 1 to negative 1 to 1, right? The reason why I remember that is three brown, 1 blue has some videos about what is it? Doing e to the x, raising e to the power of a matrix. It was very interesting. I don't know, man. I'm gonna write this company and see if they'll like send me a case because I'm gonna do a review for their video or a review for their lenses, and yeah, I don't want to have to send these lenses back. I was really excited about them because I paid $500 for 3 of them, and then okay. So what am I doing? I don't really need a thing, do I? I need a. Huh? And then divided by what? 12. Oh wait, hold on. This isn't right. I couldn't possibly do it this way. Do I need another like function to calculate the standard deviation from a sample of a bucket? Because that's just what all I'm doing right now, right? I'm going to move this into a function. I don't know what to do about these lenses. I've seen them for $550. I bet you I could find them for even cheaper. They're usually like MSRP like 1,000, and then they're on sale for $750 all the time. So 500 is not like crazy. You know, it's a good deal because they're like more than 250 when you buy them just for one. So definitely a good deal. I want to play with them. Almost tempted to put up with the case. I bet you I can get Sure to send me a case because I'm definitely gonna review the lenses. I got the 7 Artisan Hope lenses. Although I'm missing a 35 millimeter. What? This AI stuff is kind of annoying. Wait. Possibly undefined. Ugly looking case all the time. I need to stop mourning the lens case. Oh my God. Piece of shit, dude. You never put stickers on fake leather, man. I mean, there was a plastic thing the dumbass could have stuck it on. Like a price tag sticker. some paper. What an idiot. Dude stuck a paper sticker. It's like next to impossible to get off. And then he stuck 2 pieces of tape on either side of it, which did not mess up the leather. But, I mean, the paper sticker ripped off and left a bunch of, like, paper stuff on it. And then he had a label printer. And he had a label, and he stuck a label on his side, and then the label printer on the side just, like, ripped it off. And it's like, dude, what are you expecting? I mean, you're pretty much asking somebody to send the product back. Some people are just stupid. I can't stand stupid people, to be honest. They always do stupid shit. I don't mean like stupid like you can't figure out calculus or whatever. I just no common sense. They don't care. So what do I do? At this point in time, I need to log whatever the standard deviation is. I mean, really, I need to get the algorithm going and then run because it's just a little bit nebulous in some ways. It needs to be less nebulous, and then I'll worry about all that other stuff. So what is that? 2? Is that what's storing one? So what do I do with the standard deviation? Does it mean like I can't have so if it forms a normal distribution, you know, I need to have like some sort of range where I can say that this is like, I mean, if it's always exactly in the middle, that's not actually, sorry, if the if it's always like a perfectly normal distribution, that's not perfectly random either, right? So I took the what? The difference between, I have a sample. Don't I need a sample? Wait, I need something to calculate the deviation from, right? Huh. Okay, so we have to be able to take upsetting. So upsetting that they did that. It says use like new, and then they stick a sticker on it. No, what are you doing? I couldn't have stuck the sticker on the plastic handle that was right next to there. Oh my god. I just want to strangle him, dude. Glue all over it. $100 item, and you're like gonna stick stickers on the outside of it. They like new. That idiot. Okay. So what am I doing? Wait. No, I'm calculating the standard deviation from this, right? X x sub I minus x bar. So okay, so I found my standard deviation, and then what is the standard deviation again? Is that like something with pi or whatever? Making me hungry over here. What am I doing? Like a Monte Carlo analysis? How do you do that again? Am I looking just for like a clustering? Okay. I mean, if you ask me, I think, what do you do? Check bound. Uh, one minus threshold? This is garbage. Wait, hold on. What am I missing here? I'm just taking the, what, negative threshold? This one's just threshold. Wait, hold on. No, there's no negative standard deviation, right? I added up a bunch of... So I took the difference, I squared it, so it's always positive. So there's no negative, right? And what exactly does that tell me? So I added up all the standard deviations and then divided by the number of samples, which is 12. Okay, so noise threshold. We're gonna do a threshold here. So it's got to be a guaranteed finish algorithm. We have to do something. Standard deviation of what? Result. So what do we replace the sample with? What isn't it the XOR? Right? What is the sum? Wait, so I got the sum. I don't think this is right. This standard deviation thing. Don't I take the sum? I get a value, and then each time I generate a number, I store the sum. Okay, and then that sum can't deviate too much from a standard deviation. So let's say I took a. Well, shouldn't they all pass the normal distribution test? I'm back. Oh, so there's the standard deviation between the last 12 outputted numbers, right? But then what about the standard deviation of the standard deviation? Because, I mean, a standard deviation, what does that tell you? Like how far on the bell curve away you are from the center, right? I feel like maybe I should have for each of these buckets, I should have maybe some sort of random seed, extra number that I do something with. Because right now I have 12 indexes each. And I feel like I could maybe do something by adding an extra index, but I don't know. Like if I added another number, maybe I could store maybe like an extra value or something. The last rejected value, and then XOR it with the current rejected value to get a value that's not rejected. So I should, whenever I come and I get this first or the second one, right? So let me think about this. So I have I'm XORing, and then I'm doing what? XOR and some bucket. So I'm ejecting, and what am I putting in the... Wait. Okay. This is the ejected sample. Possibly I could do something with it. Yeah. I got the sum and the XOR, right? Or the normal distribution. Trying to like recreate this myself for a mathematical exercise, but this is definitely difficult conceptually because I haven't done statistics in many years. But I'm trying to go back to first principles. What does the deviation tell me? How far away from the expected average it is? Okay, so let's say one random number was not within the expected deviation range. Okay. So what would I go about doing? Would I just allow that? And then maybe like, depending on how many different standard or times that like the deviation is outside of parameters, then I would, because if I'm generating two random numbers and then like the distribution is like wildly off one time, that is random. I mean, it just randomly would be at different places in the distribution, right? Hence why it's a distribution, right? Just because it's at the tail end of the distribution doesn't mean that it is oh wait a minute, hold on, what do I do? So what do I look to see, like, if it fits the distribution, and then I need to do like some number of different algorithms until it either fits the distribution or samples index equals x4. Wait, hold on. Wait, maybe I'll call this client generated sample. Client gen sample. I'll just call it client sample. That's good enough. Oh, I don't know what to say. I don't know. Yeah, I think for for my purposes, I think I'm just done with these samples completely. But I don't think that they're like useless. I think that they're Because not everything requires a completely random number. You know, good enough random number is good enough, right? Yeah, what if I could do like a recursive, like do another one of these random number generators hooked up like from so where's the eject sample? Eject client sample? Eject sample? I wouldn't use the output random number because that one has to be like gone. It can't have anything to do with any inputs at all. So I have the eject sample. What do I do? Is the ejected sample, is that the outputted? So whenever you call the random number generator, give me a random number, is the next random number already determined on my end? Or am I calculating it right then and there? Because let's say I eject this sample, right? Isn't that supposed to be I think personally that this ejected sample should be the result. Personally. And then we're going to calculate the next random sample. Replace it. And in the process, we're going to generate another random number. So here's the eject sample. And then what is the result? So this is the result of the XOR from all of the buckets, right? Or is it like, so this sample is, we're going from the initial state. So where's the initial state is that it's initialized using a Mercian prime professional, industry standard random number generator, right? All right, so one option is I could take a list of prime numbers and then randomly select one of the prime numbers, and then one option is to cap, like look at the ratio of prime numbers to non-prime numbers in a certain bound. And I could select a random probability that it's a prime and do some multiplication based off of some statistics on a random number. So we assume I have a random number coming in that I generated with a different system, with the black box. I like the black box. So, another option is to use this number as a seed for another random number generator, like a one that's already pre-made. Or I could do so what do I think? I think that I'm going to need to have to do so my ejected sample is going to be so I can't use the client input to determine the next sample, I guess, right? So I have to scramble up the client's input significantly. All right, so let's think about this. I don't want to use. So you're a hacker. You got a list of numbers. You're trying to predict the next UUID. We want to cut you off at the pass. All right. You're red team, I'm blue team. All right. So what do we do? Call up all our friends and have a party and like blow it off. Just fudge the, make a fake research paper with some fake data. I'm joking. I'm joking. All right. So we're already using a lot of RAM. I'm using 1.5 megabytes of RAM, and that's an uncomfortable amount, well, a semi-comfortable amount of RAM. It's okay because if you just think about the number of random numbers in there, it's like, okay, well, you wouldn't be able to predict one of those numbers in there. So making it off of a combination. So let's say kind of just want to do, I'm going to need to benchmark it because like I can theoretically come up with a bazillion ways to skin this cat. I could sit here for months coming up with different ways that I could randomize these bits. All right. And that might or might not help me, but would probably be pretty useless if I don't have a benchmark, right? So I'm thinking Occam's razor here, right? Occam. Something tells me that like 50% of the historical figures that we know of, like Pythagoras, Occam, I bet they were all pedos. I bet. Like Schrödinger. Schrödinger was a legit pedo. I ruined it there for you, huh? Sorry. What am I not doing here? Right. Use left side of comma operator is onion. So, what am I trying to do? So, what does the Monte Carlo analysis do again? Would that help me? I forgot what the Monte Carlo. I remember it was really easy to do in that program. Distance of less than 1. So shouldn't over time the sum over time should be tending to 0? Sorry, when I sum up the 12 samples, right? So there's going to be, it won't be 0, but it'll like start approximating 0, right? But then as I go, each time I create another one, that deviation is going to change, but the overall deviation is going to be tending towards 0. See, I like this random number generator way better because like this is like in real time. Like I feel like I'm cracking the matrix right now, dude. Like, oh, so you mean real numbers are way better when you generate them in real time? Ah, yeah. See, I like that because, you think about what's involved with generating a random number, right? And like you're running this function, and it's just. Okay, so if I count these inputs as pseudo random number, if I could just do a Monte Carlo analysis on this. What do I want to do? Okay, so this is it. That's it, huh? Huh? S divided by N. Am I like doing a Monte Carlo right now? Without really thinking about what I'm doing? Here's the thing. What is the simulation? Is that like a pseudo random number generator or something? Well, I mean, it's whatever, but in our context, we're like running. What I want to do is I want to use like a scrambler. Like I want like my goal is that like the first pass that I go through there is going to pass like 60% of the time. And then 40% of the time I'm going to need to run just a little bit more calculating on it. And then I want to be able to like at some point in time just eject a sample to the recycle. And then we got a buffer that's got, I don't know, 1024 samples in it, right? And you can just initialize them all as random number. And then you can do like a scrambler with like I could take. The problem is I can't have the scrambler technique has to happen with prior data. So I can't have the user input in data that is then used to generate the next random number. So when you give me a number, this is going to be based off of the prior inputs to the system that are not all going to be from the same system. But maybe they are. So let's say I have a new server. I have cold booted my server. I only have one hacker on my system. This hacker knows the specification to my UUID generator. They're hacking it. Now they're going to take and they're going to predict the next one from that server. Okay? Personally, what I would do is I would set up 12 lava lamps with webcams on them. And then I would take the images and then I would overlay them. And then I would use this as a random number generator. Now, I didn't come up with that idea. I think CrowdStrike uses that. One of those big companies, I can't remember. I thought that was the coolest thing. I would not mind doing that. So what is going on? What is this squiggly again? Isn't that lowercase delta? Delta, right? We're on. Okay. And then gamma is what? Ri minus mi minus 1. And so this is the thing is, okay, what I should be worried about is poisoning. So I think that what I've been doing is more than enough to scramble the bits, because you get XOR 12 of the last numbers together, and then you XOR 12 of the last client generated numbers together. So now I get a potentially poisoned, but should be good pseudo random number. All right. And how would you poison this? So they're never going to know what the next exponent is. So that's one way that I'm able to completely block off a large number of the attacks, is by utilizing the buffer has 1024 buffers of 12 random numbers. And so whenever I XOR these, there's always going to be the exponent for the next one is always going to be completely private. But it needs to have some elements of randomness to it. Because you got to think, I'm coming around, I'm going to be in a loop here. And then but what I want to do is I want to be able to swap out how do I swap out a sample? Random, push random, push random. I'm just going to replace this replace random. Random. This is a hook that will not be called, and this is going to be won't be called in the main process of generating the numbers. This is going to be like fuck. What do I do? Okay, so one way that I could go about doing it is like some random bit flips. One way that I could go about doing it is I could create a table of functions, like maybe 16, 32, ... functions that I could use to scramble the numbers. So let's just assume I have a Mercine Prime number generator I'm running either on a different thread or on a different server. Probably on a different thread. Because, you know, you can, your database, it's not like your database is like doing all these floating point division calculations all the time. So it's not really a problem for another thread to be calculating our random numbers while our web server is serving numbers. The thing is that we just want to be able to replace one of the samples. So let's say that this is just a random. No! Replace random. So we're going to take the exponent out of this mofo. What if I want to calculate the standard deviation of the exponents and the bits individually. So let's do replace random. So we're going to do const exponent equals random over 2. All right. Const bucket number So now we want the leftover. Equal so we want shoot. So we're gonna, here is a problem. So we need to do a random so we have 12 samples, okay? So if we want to pick a random sample, right, we're going to have problems, right? So that's why I have let's just it's going to be more accurate if I have a larger amount of samples. So if I'm doing like picking one random number out of 12, this is highly problematic statistically. But if we did our whole 512, what is it? 1024 times 12, right? And then it's divided by what? Might as well just pick one random number out of. What do you do, like modulo? How many bits? Like, how many bits do we have left over? So we got our exponent's 10, right? I haven't put the sign bit back. Replace random. The exponent's nice and easy to get. I could just replace the sign bit, or I could use like an if random less than 0, and then do one thing. But I have to pick a sample out of the thing. Bucket number. It's, oh, where did this come from? Bucket number. Oh, the autocomplete, obviously. Shift, and then we do. Shift -10. Or I just keep this in play. And then int equal random x4. So this is the integer. Let's just call it random. Random. Okay. So now we have a positive integer from, negative max or negative min to positive. Sorry, the lowest possible safe float and the highest possible one. So now I have, what I would like to do is just steal the rest of the bits on here whenever I replace one. replace random. One thing that I could do is I could modulo the, what am I trying to say? So the total different number of samples that I would be like replacing one of is 512 times the sample count, which is, wait, hold on, 10, no, it's 1024. Times 12, so it's 12K times 64 bits. All right. So we have random integers. Let me XOR off that. And my bucket number is I do. So bucket total. Well, bucket count times sample count. So what is it? Exponent bucket. Times sample. Bucket count. Wait, hold on. Plus 3. Is that true? So there's the last 12 client generated numbers. There's the last 12 generated numbers. Then what do we have? I mean, I could put my samples and then I could put like beyond that, I could like maybe store all my standard deviations that I've had, calculating out into like some X number. That would be cool. That would be acceptable. we do? What do we do? What do we do? The bucket count is. All right. I don't know if I need. I don't know how many different the past standard deviations I would store. So what would be the, so let's say, so the standard deviation should be, because I'm summing up 12 random numbers, right? So the standard deviation is going to be centered around 1. So that's going to make our math a lot easier. Let's see the sample total. Plus 3. Sample total. Spare number count. Sample count. What's sample count again? 12. 1, 2, 3. Spare number count. I don't know about that. Deviation. Math. I don't know, dude. I don't know exactly what it's supposed to be. Like, what, one standard deviation? I'm just going to start off with 1 because I have no clue what it is. So, 1. Good as a number as any other number, right? Spare number count. I don't know if I'm using this one anymore. The reject count. I don't know what I'm doing with that. I'm going to delete it right now. We take reject client sample. Reject sample. So this is the random number, right? Because the thing is that I can either take a sample out of the 512 buffers of 12 random numbers, and then I can return that as a random number. That's not a bad idea. Because then I replace that number with another number. Okay. So when I eject a sample, I can reuse some samples. So one option is I could take, so here's the ejected client, ejected client sample, and then the ejected my exponent. I'm just going to call it a sample. So next, I gotta pull the number out of the do I have to generate? Well, I don't actually have to. Okay. Now I'm going to take, I have to store the random. And I don't, as far as I know, I don't have to do anything with the last. So that I really should have, I shouldn't be doing this like this. Right. This should be this should be sample count. In case I want to reprogram that. I should do also that's not what I do. So XOR and sum. So what do I do with the XOR? So I took the XOR. Okay. Maybe I want to use the square bracket syntax here. Because I can't change the name of this and then not the sum. So what am I doing? Wouldn't it be nice to be able to just follow somebody else's algorithm, huh? But that wouldn't be as fun, right? So we got I kind of don't like how this has the bracket. XOR is some bracket. Aren't I supposed to just like throw this into a black box? Because how I generate another number based off of the pseudo random number should be I mean, I had thought about upscaling my random from 64-bit to 128. Especially if I could just get it to be temporally good enough. Because I can only generate so many UUIDs per second in this library. So if I could make it so that temporally I can always scale up. So I couldn't just continue to do that with the same current set of random numbers and UUID. But given that I have a certain timestamp, I think I could do that. I like just using the XOR of the buckets. I mean, another technique is a hash. So we would take the largest possible 64-bit prime number, and then we would multiply that by, or we could do like a 32-bit hash with a 64-bit upsample with this JavaScript number. Didn't I have calculated 2 XORs? What am I doing with it again? So I have an XOR from the last client's samples, right? And then I have an XOR of all of the random numbers in the bucket. So I don't want to just like run my algorithm on cold data all the time, because then I'm going to be slashing off giant portions of the domain, or sorry, the range. We got to maximize that dynamic range, you know. Pixels got to be popping, right? Wait. Oh wait, client gen bucket. Client gen bucket export. Prior gen one. So what do I do? Bucket count. Wait. So now I have two. Oh, I need like a component bucket count. Wait. I don't like the terminology. Okay. Oh. 3. Random sample. I mean, I could have like a higher velocity random number thing. But wait, hold on, what happened? Prior output. Did this thing auto-gen this? Get total. What is this? Sample total? Huh? I'm confused. Sample total. That couldn't possibly be. Sample total would have to be at least this plus something else. So plus, what is it? 3 times the sample count. That makes more sense. So additional buckets. I could make that. We call it a extra exponent bucket. Export that const extra exponent bucket 3. Okay. Now we could do the maybe yeah, I think I should probably it's a little bit confusing, but what do you want me to do? Like hold your hand? Hold on. Exponent bucket start equal. Extra exponent bucket times bucket sample. Got it. What is this? I could store in here, I could store the standard deviation. Something, I don't know. I used to have a pseudo random number thing in there that I think was kind of silly and not well thought out. Hmm. What's going on? Oh. Type it in. I'm not the only one that's doing that. Okay. Uh-oh. Oh, wait. Huh? Did I not do that? How do you do that again? I forgot. I haven't programmed in TypeScript in a really long time, so you'll have to forgive me if I'm being retarded right now. Result exponent. I don't know. Hold on. Possibly undefined. Huh? Uh-oh. Excuse me. Huh. Maybe a lot easier if I could just round this up to like an even number of samples. So what do we got? What's the total here? At this point in time, it is 3 times plus 10, 20, 4 times 12, right? So that's just 10, 24 plus 3 times 12, right? Okay. So this is the number of samples. So what do I need to do? Like I could take the rest of these numbers and then run a scrambler with the rest of them. So let's say I took to the 64K. 964 is 4 megabytes. That's a lot of numbers, random numbers to generate upon boot. $65,536. That's going to be a lot, though. I guess I should try to get to the point where I even generate it first, so I could tell you what's acceptable. Replace random. Let's just replace. Bucket number. Random. Shift. Replace. Hold on. I'm confused. So the exponent, is that the... Maybe I need a sum exponent function just to test. Because I might want to put like a console script for this. Just so I can see. Let's do some bucket, hold on. Bucket exponent. Okay, so now we're gonna do a for. First, let's check. Bucket number was 0. Bucket. How do you do not a number? We'll just do name. Yeah, I don't really like pausing to wait to see the AI generated code to like see the output. I think this is just noise. Wait. I'm gonna take this one of these bits off, right? Hold on. I need to move this, shift the sign bit over. So I'll do this. Then I'll need to get the exponent and mask it on. So wildly off. This is just like a useless point. The computer, the LLM is so bad at programming compared to me. It's never gonna like output what I want. Sometimes it's wrong. I don't know. Every single time that it like does what it wants is like that time saving is completely negated by every other time it's suggesting something that's wrong. All right, so step one, we get the exponent. So we shifted it over. see. Feel like maybe I should not try to over optimize this. So that's the sum. So sum bucket mantissa. Now we're going to take the okay. Sign mantissa. This will work. The next thing I need to do is I need to print debug information to the console. What I need to do, I need to do a standard deviation on like all these things. Everything. No. I could take any random number and then do a standard deviation from that number. For right now, I want to do uh, and what do I want to do? Maybe I need to do the maybe I'll just it's a little bit hard for me to whenever I get a bunch of those things. It's going to be difficult to do if I don't do a constant. Oh, JavaScript. I always do that in C++. Yeah, probably don't need. Right now, I'm just trying to get some stats. Did that one right. Yeah. Just want to repeat the same for the last generated output. All right, well, I think I'm going to hop off this live stream because I'm hungry.